So as we spend a lot of time to talk about this step effect in the different input pattern, it will impact our noise level. So you see here is I hope you still remember it, because it's a very we analysis this problem several times. So if this is the A is on first, and then this other B is from 0 to 1. So here is you see this one is this will already turn on. So this is if you will turn on the M1, this more strong and strong strong 0. So this transfer curve will shift to the left. On the other hand, if they turn on at the same times, this is the little charge. Need to turn on the device at the same times. This both PMOS are turned on. So this will be strong P. So this will be strong 1 here。所以你看这些这个东西，其实你们懂了，这些考试还是会考一些偏 concept 的事情就是你看懂了这个，其实就是可能会问你在不同的改变的时候，这个曲线长怎么样。So we also studied the delay. Delay. This is the network here, and then for this one is for 1 to 0. 1 to 0. So as we discussed before, if 1 to 0 and B is on first, you need to charge up both capacitance. So on the other hand, if this high to low, it will be this is the most slower one. A and B all is from 0 to 1 because you need to discharge these two capacitors at the same time. So this is I think is very basic and then very straightforward. This kind of skill still will be used in your future career. So it's important. And then go ahead. This is some basic concept of how to define the delay, propagation delay, accumulation delay. And then this is how to derive this equation. And then PMOS, sometimes it's 2 times, sometimes 3 times, depends on the process. So we will make this level in this way. So this is the gate. So we remember why we put this is 2, 2, 2, and then 3, 3 here. This need to equivalent to this inverter. And this 2 because the mobility is lower. Lower. So you write down this kind of network, and then also you learn about the MO delay model, how to calculate. In the exam, one equation we test this one. To the concept, I put some slide to help you to understand what's the MO delay model. And this is some delay estimation. So this is more from the circuit to understand how to calculate the delay. R and C level delay. So after we learn how to calculate the estimated delay, so I provide some methods to you before is the logic effort. This is parasitic. This is the G and H product here. So this is very useful. And then what question will become from this part to calculate something about the G and also the P here. So this is a small capital. Small capital is the single stage. So this kind of equation, remember in the work file is included. So don't need to remember other things. Just you need to know how to calculate. It's okay. So maybe you can do some exercise. If you want to, I don't make any homework, but actually we do a lot of exercise in the class. So sometimes you calculate, you can use this kind of equation. How to use this kind of equation to get this result. 这个 table 会给你们不用印记。So how to calculate the product, parasitic. And this is the parasitic. And then this is very important for your multi-stage calculation. 这个你算到这个 multi-stage 的时候，你直接放这个 table 来用就好了。multi-stage logic level. 这个会考哦，这个 this one you include in the exam. So a lot of exercise. I remember we have one exercise from input calculate back to the output. From these two input and output to estimate the device size in this logic. You use this kind of equation here. So you need to use this kind of example. You can calculate one several times to make sure you can get this kind of skill. So this is the bench. You have two bench, so you need to including this one. So this is the GBH here. And then also this one is included in the table provided to you. How to calculate the delay. You get all the things and how to calculate the delay here. And then this one is to based on this head F equal to F power 1 over n. So you can calculate this head F. Head F is very important. You need to calculate the Cin. So I summarize this one in the slide 55. You make sure you understand this one. How to use this slide to do the calculation. This slide is provided to you in the exam. And then this is one example. You can use this one. Get a G and an H is very simple. And then this sometimes will be one. Make sure you understand this meaning. Sometimes we will add another bench in here. How many stage? How to calculate the head F? How to count the P? You can use the table. And then at the end, you can get this minimum path delay here. 这个你们还是要去练习它算一下，因为考试还是会考这些。So another example. So you have another in the same stage. You have different driving, different bench to driving. So this is this one. How to calculate the buffer? How to calculate the buffer? We do this in the homework in the class. We do the class exercise before. So be careful if you need to find the. If we find the n here, find the minimum delay here, we need to put the 0 here. So in the calculations, you get these equations, and then because you cannot allow to use the computer, so you need to do some substitution, and then to get this result. Put several number on it. Maybe we already know that this may be something like the stage is from 2.4 to 6 something, so you can put 2, 3, 4, 5 to see what's the changing of this delay here. 我用中文讲一下，就是你这个 derivative 去找这个 d 的最小的嘛，这是最小值嘛。那你在考试里面不允许你拿电脑进来嘛，所以你要做一些 substitution， 然后你聪明一点，就是你看这个 slide， 它大概的方法就落在这里，你就 substitute 几次，然后大概看谁是最小的，就可以找到了。Some skill when you don't have the computer, you still can get the derivative 0。这后面都 substitute 这个 equation 也给你们。So it will be some, because the calculation is very standard and very provided equation to do, so the weighting is not too heavy about this calculation, about 10 points, 10% of this exam. But you still need to spend time on it. 这个就没了。This one, some key comments you still need to digest, and in the true and false we will ask this one. So ask the So we talk about the power interconnect. These two will be including some question in here. So power is very important, and then we do a lot of switching related. Switching related. So because this kind of things is very general equation, and then this is subversal leakage. I think is relatively important. You have to how to analyze, because we spend a lot of time to talk about this line. So you need to make sure you understand what's the meaning if the input pattern is different. What will be the impact on the gates and the subversal spring, subversal leakage? Because this depends on this floating point Vx here. They will impact the leakage and then the subversal leakage. So these V operation conditions. Still, very quick capability to weigh down these things. If you know the device, know the what we learn in the device, I think it's very easy to do. And then this kind of skill will be in the permanent. I think even right now, I still get very fast to weigh down this kind of things. Interconnect is very important. We have some general questions about the background, some general knowledge about the interconnect. So this one, because in the exam we still need to do some calculations. So this pi model, I need to make sure you understand this, and then you be careful. This is C over 2, C over 2, not C. So when you do the substitution, you be careful to do the calculations. So we will including some example in this slide. I moved very fast, but doesn't mean it will be happen. Maybe in some true and false also. So yeah, this one. Before you do the calculation, you need to know how to calculate the resistance of the interconnect. So you actually, I will try to make the final exam, because make you to, if you do some class exercise in the class exercise, so we will put something in the final, or some example. So this one, because for this one, this resistance is calculated by the last example. So this is just the pi model. So as I said, be careful. This one, this is the half of the C, and then this is the input, this is output, and then I make it more simple. Is we assume the this is no gate diffusion capacitance. This one is, you can find it in the textbook. Make sure you understand how to calculate it, and then use the L or delay model to do the calculations. So I think this is very important for the interconnect. These two you will check it in the textbook 6.1 and 6.3. Make sure you understand how to do this kind of calculations. yes, crosstalk is very important. And then this one is some basic concepts how to understand crosstalk. Because I think 10 years later you didn't forget a lot of equation, but I hope you still remember what's the crosstalk. So you see this is positive crosstalk. So this is our propagation signal to here, and this is the opposite side, opposite. So it will make these delays of this signal longer because you want to propagate and then it will be changed to another side. So this is another one is the negative crosstalk. If these two signals is in the same, if this rising also this is rising, and then it will get earlier. Because you see here, this is a resistance here. No resistance. Yeah, this is no resistance. So not difficult. I think I want to test you something you will remember in the permanent. But sometimes we need to do some calculations. So if we want to solve this crosstalk, we can reduce to minimize this capacitor junction, this capacitor adjacent capacitor, or make the driver here, return resistor here. This is very general concept, not too difficult to remember. Okay, so this is the key points of the lecture 9. Design module also is very important, but I want to make sure you learn the key points here. So, for example, if we want to make the fast corner, how can I visualize it? So we can make the channel shorter, weighting lower, and the outside thinner. So this is very straightforward. Even you didn't take this class, I think if you are good engineer, you should know that. So if you want to make the device drive much faster, VDD increasing or cooler the device, it's very simple. Reliability is very important. So I will maybe ask something about the reliability, for example, hot carrier and then maybe TI. But there's some general concepts. Don't need to remember a lot of this kind of ports is meaningless. Key concept. And if something related to the circuits, I think the lecture is very representative. So you make sure you understand what's the meaning of the lecture. The lecture is very important. I hope you to understand it because it will be very useful in your future in the circuit design in the silicon device. How to solve it? A lot of possibility. Scaling. Scaling a little bit confusing. Yeah. So in the future, we will go to the low K and copper. No need to go for everything. You can read it by yourself. 今天讲完就会下课了，要你们回去复习。This is the one of the important chapter. Very important chapters. We still learn the static CMOS. So very basic concept. As I said before, CMOS, standard CMOS is very traditional and conventional. So only one network is conducting in the steady state. Key concept. And then input pattern we already discussed. Yeah, so some school scale gates. Yeah, so this one, how to calculate the best P if I want to switch on at the best, the farthest capability. So also weight-shouldered circuit is we learn a lot about the weight-shouldered circuit here. Pseudo NMOS here. So this will go faster. You learn it. This one, if you ask you how to design if our circuit is always one edge is favored. So if you make this is the rising. So this is preferred for this one. This is the unskilled. This is high skill. 这个就把上面那个缩小，因为它也不常开，不常 switching. Yeah. So there's some skill. You can go ahead. You can try this one. Make sure you can understand how to calculate the G here. One question you ask how to calculate the G. Make sure you learn that. So. And then asymmetric. Some true and false we ask it. And this one. How to get the best ratio. So as I said, sometimes the mobility is 2, sometimes it's 3. So it's changing. So make sure you learn how to calculate this P. This is some equation. We go through how to develop it. And what's the mechanism here? So this is very important equations. Very important. Based on this one, you can calculate the best ratio. No need to do a lot of no need to derive, this derive the equation. So you can try to make sure you understand it. This is one of the examples. Ratio, I think the most representative one is the NMOS. So very important. This one. CMOS is independent, but weight-shoulder circuit is dependent. Very general concept. Because this is, if your ratio change a lot, this will be function problem. Concept, very simple concept. This calculation relatively complicated, so I will not test it. 这个我觉得没有太多需要你们算这个没有意义。So this one, concept is very important. This one, so the NMOS low gaze is better than static one. Very important concept. 太复杂了就会 so difficult calculation for the NMOS. You need to just read it and then you need to read the Excel. Okay, so this one we talk about the dynamic circuit. Very interesting one. So make sure you learn how to write down this waveform. Not exactly this one. This kind of time diagram, maybe ask you to draw it, because we, in the class exercise, we also learned it. This concept, dynamic symbols, what's the operation principle, and then how to be operating. Some key concept here. This is your margin, dynamic circuit, inverter, the loss margin is smaller for the lower loss margin low here. Depends on the VT. Also depends on when you pick up this data. Two factor. And this is the dynamic. Still, just make you to learn how to calculate the GMP. And this kind of dynamic circuits is one key issue, is the monolithic rising, monolithically rising. This is the first criteria of this kind of circuit. 这个是它的最麻烦的地方。So this is some. If you write down this one to describe this problem, you need to more useful. Because I just want to test you some concept. If you are asked what's this kind of issue, you can use this diagram and then include some wording, because we do the exercise here. And we can use these circuits to solve this problem. High skill inverter. So this is okay, power. Some general question that we asked in this part. Some very general questions maybe. And I think this is the key issue here. Dynamic circuits, we always facing a problem is this some leakage, and then some charge sharing issue. Charge sharing issue is very important. You will see here if you are, this is the NAND gate, and then this charging issue will make the output is incorrect. And then this governed by this equation. I think this equation is very simple. Just a capacitance potential sharing equation. And then one of the solutions is to make the P-charge transistor again here to push up back this output. Okay, so this some pass transistor. Some general question will be asking here. Yeah. Also, will be used in the following. Some pass gates, transmission gates will be used in the flip-flop and latch part. 我只讲重点哦，你们不是说其他不能看。因为太多slide close to 600 slide, I just want to make sure you get the key points. But doesn't mean others is not will be included in the exam. Another key the topic sequential circuit. Yeah, this I think is very general concept. What's meaning? How the latch operate? How the flip-flop register operate? So this is the very key timing diagram, and then you see the latch is the level checker, and then the flip-flop is the edge checker. Key concept, and then. This is the 1, 2, 3 different kinds of operations. someone will be a very some benefits for the clock driven 有一些对 clock driven 比較不敏感的 so some latch operation and then this is very basic concept about the stable circuit. And then this is the latch, one latch, and then operate in this. The symbol is here, the detail is in here. How to operate it, and then you see here in the class, some class may ask me why sometimes you need an input here or the another output here, and then this is very interesting. You are in a buffer here. Can it solve some problem? And then also you add another buffer here, and then you can solve the because this one is your data will be stored in here, and then if you directly connect it to the outside, will be maybe impact your these points the voltage. So you add a buffer here. It's very useful for the buffer output. So this is the circuit. If you skip the input here. So this is another one. This symbol can be realized by this one. So this is the flip-flop, the register, how to make it. Master and slave. And then the clock, you see here is opposite. This one will be us. This master and slave will be us. So you be careful about this one. This make sure you understand how they operate and how to calculate the setup time. And then this call to kill time. Whole time sometimes if you assume the clock is slow drift, but clock will be sometimes to be drift here. Some problem here. Some in the this static. Okay, dynamic here. Dynamic is operated in this circuit. So I think these two most important registers. So make sure you fully understand the details about these two registers. Maybe ask you to sometimes so calculations about the setup time, hold time, and hold delay, and how to write down this diagram. And then provide the operation mode. Yeah, this is some clock drift problem, and okay, so this is the register. So we can this dynamic register be realized by this call to MOS. Some information I just want to share to you, but this one will not be happening in the exam. Make sure you. Yes, this one. This chapter is still very important. This one, how to calculate this kinds of delay circuits here. And then this one is the first one, the maximum delay of the flip-flop. Your clock here, and then you have clock to Q here, clock to Q here, and then this is the propagation delay of this logic gates, and then back to here is the setup times of the next clock. So you remember it is we spend 8 minutes to calculate this one. I think this is most important. Maybe you're curious why we need to add the register. It will make our circuit, the latency, slower, longer latency. But if you make the register in somewhere, you can improve the frequency, the circuit frequency. So I think it's very important concept. Make sure you understand it. It's the key of the Pi 9, the motivation why we do the register and then do the Pi 9 calculation. So also some general concept we asked in this kind of slide. But we will not do a lot of calculation here. So this table is very important. Some key information you can find in this table. But I think the concept is really not difficult. This one, flip-flop, cannot support the time borrowing. This one, plus fast, but the time borrowing and then the scale tolerance is not as good as this two-phase one. Simple concept. Don't need to remember all the equation. I don't test on this one. Remember some key concept is enough. If we do the calculations, we will provide the equation to you. Yeah, this one is, I think the key is this one, and multiplier and something. Yeah. You make sure your adder is, you get all the information. Adder is some question asked this one. Adder, full adder, and ripple carrier adder. So this is the architecture of this ripple carrier adder. So this most simple one, and then this one is much better. We use the generates and propagates logic to do some P calculation first, so we can achieve this 1, 2, 3, 4 here. So this concept is relatively important. So you make sure you understand, as I said several times, generation don't need to care about the input. Key concept. You go through this table to make sure you understand this concept. Some generation A and B, D is A bar, B bar, P is A exclusive of B. And then I spent close to 3 times to talk about this step fee. Step fee is relatively important. And then make sure you understand how to do this kind. You can go through once, and then you can know how to understand this one. But I will not ask you to do the calculation. I'll make sure you understand the concept. And then we'll ask you maybe in this circuits how to add some parts in here and to explain this one. And so also we use this symbol. So for the bypass we actually use this equation to do some P calculation of the P. So this is the architecture of the one box. So you can use this one to build this circuit. Make sure you understand how to write down this circuit. This circuit actually use the concept we already discussed. Calculate the P and then have a multiplexer here. And this multiplexer will input in the C in, and then another input is from the adder, and then pass to another one. Key is here. But you need to explain this one. It cannot be just remember this one. You need to understand what's the operation concept. Why can it be faster than the ripple? And then look ahead, and then we calculate more items here. The key of this look ahead is P calculate G and P also, both. And then we paste this multiplexer by this N low. And this input still input to the N here. So if you go back to this equation, you see this P41 G00 input is in, and then all this G here. Make sure you understand this operation concept first, and then you try to remember this one. And then the slack, I think, is if you understand the previous two adder, you can. This is not difficult. You calculate all the things first, and then use the multiplexer to choose which one to do the choose the. I select the 0 or 1 and then pass to here. Concepts simple. So as I put these two pods together, and then this ripple is the slower one, and then bypass is faster, and then this slack should be much faster because you already calculate all the things. Just do the slack. This is the subtractor. Multi-input adder. Multi-input adder. You before we learn it, is the 2 input and 1 output, and then the carrier safe addition is 3 inputs, 2 outputs. And then we always spend 5 minutes to do the exercise. I hope you learn how to calculate. And then the multiplier. We learned that is the multiplier, the array multiplier is the most slow one, and then this carrier safe multiplier is much better. And then this is the voluntary multiplier. So the key concept of a voluntary, I hope you remember it. But we don't ask you to do a lot of calculation in this part, just some key concepts about the multiplier. And detector counter also, some general concept. And shifter, I didn't put any question in the shifter. Okay, so hope you can get some feeling what will be exam. And then the key is some key concept. Some calculation you asked me to do, but the equation we provided to you. Okay? So hope you will be good luck in the exam.